Welcome to Physics Help. In this class, we will go through some of the NEET previous questions from the topic electrostatics. First question. If the distance between two charges is doubled, the force between them remains same, doubles, becomes half, becomes 1/4. We know the Coulomb's law, the force between two charges F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R squared. It is two charges Q1 and Q2 are separated by a distance of r, then the force, electrostatic force between the two charges F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R squared. Suppose we increase the separation distance to twice the earlier distance, that is 2r. What will be the new force? Let's give the symbol F dash for the new force, that is F dash is equal to 1 by 4 pi epsilon 0 into Q1 Q2 divided by 2r squared. That is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by 4r squared. This 1 by 4 pi epsilon 0 Q1 Q2 by r squared is nothing but F, that is F dash is equal to F by 4. Therefore, the new force becomes 1/4 of the earlier force. Therefore, option 4 is the right answer. Let us proceed to the second question of the NEET previous set. A charge Q is placed in the center of the line joining two equal charges capital Q. The system of three charges will be in equilibrium if small q is equal to, options are capital Q by 4, capital Q minus capital Q by 4 minus capital Q by 3. Let's draw a diagram. So there are equal charges, capital Q charges. Let's say they are at a distance r, and we place at r by 2, that is at the midpoint, the line joining the two charges, we place a charge small q, and we should find the value of small q in terms of capital Q such that the system of three charges is in equilibrium. The condition for equilibrium that each of the charges should experience zero net force. Let's take the case the capital Q charge. The force experienced, let's say F1, this is the force experienced by this capital Q charge due to the other capital Q charge, that is K into Q divided by R squared. This is simple Coulomb's law. The force due to small q charge on capital Q charge F2 is equal to K into Q divided by R by 2 the whole square. So F net on this first capital Q charge should be equal to 0. That is, F net is equal to F1 plus F2 is equal to 0. That is K into QQ divided by R squared plus K into QQ divided by R by 2 the whole squared should be equal to 0. Removing the common factors, we have Q divided by R squared plus Q divided by R by 2 squared is equal to 0. That is, Q divided by R by 2 squared is equal to minus Q divided by R squared. That is equal to, Q is minus Q divided by R squared into R squared divided by 4. We cancel this r squared to get minus q by 4 as the answer. Therefore, option 3 is the right answer. Let's see the third question of this NEET set of questions. An electric dipole is placed at an angle 30 degree with an electric field of 2 into 10 to the power 5 Newton per Coulomb. It experiences a torque equal to 4 Newton meter. Charge on the dipole if the dipole length is 2 centimeter is option 1 8 millicoulomb, option 2 2 millicoulomb, option 3 5 millicoulomb, option 4 7 millicoulomb. So this is a case of simple substitution in the formula. As we said earlier, tau is equal to P cross E, that is PE sin theta. So the parameters here, the dipole moment P, the electric field E, theta the angle, all these are given in the question. If P is equal to 2LQ, the dipole length is given in the question as 2 centimeter. That is equal to 2 into 10 to the power minus 2 meter. The electric field, the magnitude of the electric field is equal to 2 into 10 raised to 5 Newton per Coulomb. The torque experienced in rotating is equal to 4 Newton meter. The angle theta between the dipole moment and the electric field is 30 degree. Substituting into the formula, we have 4 is equal to 12q E sin theta. That is equal to 4 is equal to 12, that is 2 into 10 raised to minus 2 into q into 2 into 10 raised to 5 into sin 30 degree. This 2 and this 4 get cancelled to give 2 here. Q into 10 raised to minus 2 into 10 raised to 5 into 2 into sin 30. Sin 30 is 1 by 2. The 1 by 2 and 2 get cancelled and we have 2 is equal to Q into 10 raised to minus 2 plus 5. That is 10 raised to 3. That is Q is equal to 2 into 10 raised to minus 3 Coulomb. That is 2 millicoulomb. Therefore, option 2 is the right answer. Now let's see the fourth question. A charge Q is located at the center of a cube. The electric flux through any phase is, we have 4 options here. And for your information, this is a typical question asked in entrance examinations like NEET, National Eligibility Cum Entrance Test. Let's see how we can solve this problem. So it is given that there is a cube of some side A, and at the center of the cube a charge Q is placed. And we have 6 faces for the cube. We'll have to find the electric flux through each of the faces. And from the symmetry of the problem, we can understand that the flux through each of the face should be equal. So from Gauss's law, so assuming that this cube is a Gaussian surface, from Gauss's law we know integral E dot dA is equal to 1 by epsilon 0 into Q enclosed charge. So here small q is the enclosed charge. Therefore, electric field into integral dA is equal to Q by epsilon 0. This phi is equal to Q by epsilon 0. So by the symmetry of the problem, the flux through any phase should be phi by 6. Phi divided by 6, that is equal to Q divided by 6 epsilon 0. The flux through this phase is q by 6 epsilon 0. The flux through this phase is q by 6 epsilon 0. Likewise, through every phase of the cube is q by 6 epsilon 0. Therefore, we can find that by removing this 4 pi and 4 pi, we get q by 6 epsilon 0. No other answer, no other option gives the right answer. Therefore, option 2 is the right answer. Next question. The electric field at center O of a semicircle of radius A having linear charge density lambda is given as 2 lambda by epsilon 0 A, pi lambda by epsilon 0 A, lambda by 2 pi epsilon 0 A, lambda by pi epsilon 0 A. So there is a semicircle, a charged semicircle is given. The charge density is lambda. And this is O, the center. So let's consider a line element dl. So since there is a linear charge density of lambda, the charge of each line element dl is equal to, q is equal to lambda dl. Therefore, it will have an electric field at O. Say dE. This is a semicircle of radius A, and also it is this dl component is making electric field is making an angle theta here. Therefore, we can resolve it. This angle is also theta. We can resolve it into dE cos theta here and dE sin theta. Consider a symmetric component on the other side of the y-axis, dl. This element will have a same dE electric field. It would be like this, dE electric field. And it will also have components. Let me draw it here. This is O and dE. This is theta. We have dE cos theta here, and here we have dE sin theta. The other dE, we have, this is theta. We have dE cos theta here and dE sin theta here. The sine components add up while the cos components cancel out. Therefore, the electric field at the center of the semicircle is actually the integral of all the contributions of all the dl components. That is, electric field at OE is equal to integral, we are integrating from 0 to pi dE sin theta. dE being the contribution of the dl element, dE is equal to k into lambda dl, that is a charge, divided by a squared, the radius. It's electric field due to a point dl, lambda dl being a point charge, we are considering it as a point charge. dE is equal to k lambda dl by a square. Substituting it here, we have 0 to pi k lambda dl divided by a squared into sin theta. But also we have arc by radius formula, that is, for a small arc of dl length, it is having a radius of a, let's say. And if it is making an angle d theta, dl divided arc by radius is equal to d theta. Therefore, dl is equal to a d theta. Substituting for dl, we have k lambda integral 0 to pi k lambda d theta a sin theta divided by a square. So a and a get cancelled and we have 0 to pi integral k lambda sine theta d theta divided by a. Therefore, we have E is equal to k is a constant, lambda is a constant, a is a constant, integral 0 to pi sine theta d theta. Integral sine theta is minus cos theta, and we have to give the limits from 0 to pi. It is k lambda by a into minus cos theta limits 0 to pi, which will give you 2 as the answer. That is 2k lambda divided by a. That is 2 by 4 pi epsilon 0 into lambda by a. The 2 and 2 get cancelled, and that is E is equal to lambda by 2 pi epsilon 0 a. This is the right answer. Electric field at the origin O of a semicircular arc of linear charge density lambda. That is option 3 is the right answer.